Hey guys, this video is dedicated to the last problem in the titration lecture, which is lecture 3 of unit 2. So this right here is the problem that we are going to be solving together. All right, so let's take a look at how to do this last one. You should have the problem in front of you through, via your slides, of course, but it gives you a balanced reaction between copper and nitric acid, and it's trying to figure out how much of the 16 molar nitric acid is required to react with a measured amount of copper. So if we go through our titration steps like we did during lecture, we know that we first need moles of our given. So in this problem, it says that we have 0.345 grams of copper as my given. So let's go ahead and simply convert him to moles. All right, track it across the top. We're going from grams to moles of copper. The diagonals will match the letters. And I know that anytime moles is being compared to grams, that 1 mole equals periodic table grams, which for copper is 63.55, since it's just Cu. All right, so if we run this grid, all right, multiply and divide, we're going to get a mole count of 0.00543 moles of copper. All right, so now we've got our moles of our sample. Now again, we're going to want to compare the moles of copper compared to the moles of nitric acid required to make the reaction go. So this feels stoichiometric, but our steps from lecture said that once we have moles of known, let's convert that to moles of unknown. And this question is asking about nitric acid, so that's obviously our unknown. All right, so we're going to want moles of that. So let's make the diagonals match. Now moles is over moles, which we know always looks at the coefficients of the balanced equation. All right, so if we look here, we can see that our coefficient for copper is 1, our coefficient for nitric acid is 4. Copper is 1, nitric acid is 4. All right, so let's run this value, and you'll see that we've got 0.00543 times 4 divided by 1 is going to give me a value of 0.0217. And now we've got moles of HNO3. All right, so now we can take our moles of unknown and convert to whatever we want to convert to. And if you look here, it wants to know how much. How much is referring to a volume. All right, so if we think about our regular molarity equation, all right, it's basically wanting liters. So the other given value from the problem is 16 molar. All right, so I know that my molarity then is 16 molar. All right, the mole count that we have, we just figured out. All right, so my moles is on top is going to be 0.0217. All right, and we're going to solve for x here, which is liters. So, all right, we can cross multiply here, and we're going to end up with 16x equals 0.0217. All right, let's divide both of them by 16, and we'll get an x equals. All right, so let's take our 0.0217 divided by 16. You're going to get that number there. Now, remember, this is spitting out liters, which is fine. So we can write that number down. To only 2 sig fig is going to be 0.0014 liters. But keep in mind that there's a chance that it could ask it for the answer in milliliters, since milliliters is going to be probably more commonly used in the lab. So while this could very well be the end of the question, remember that to go to milliliters, the unit would be getting smaller, so the number would get bigger. So I could slide the decimal to the right 3 times. So this would, again, it would be the same thing as 1.4 milliliters, which would also be fine.